we're going to do Leetcode 234, the palindrome linked list. So, given the head of a singly linked list, return true if it is a palindrome or false otherwise. So palindrome is something that looks like this, where it's same if it's flipped. So 1, 2, 2, 1 is a palindrome because if I flip that, it would be 1, 2, 2, 1 going backwards. Similar, you got race car. If you flip race car, that is also a palindrome. So we're going to do this with a linked list. So the input of the head is 1, 2, 2, 1. So obviously if we flip that around, that's going to be true. If we have a head that says 1, 2, it's going to return false, since if you flip that, it'll be 2, 1, which is not a palindrome. The number of the nodes in the list is range 1, 10 to the 5th, and the node value is always going to be between 0 and 9. We're going to try to do this in O of n time and O of 1 space. So we're going to take care of a couple edge cases first, and then move on to something called, I believe it's the tortoise and hare algorithm, where we have a slow pointer and a fast pointer. Fast pointer will move twice as fast as the slow pointer, and then we will reverse it and then compare the values and see if it is in fact a palindrome. So initially we're going to do if head is null, or if head.next is null, then we're going to go ahead and return true, because if you flip those, that is also palindrome. So that is an edge case. So we're going to let the slow equal head, and also let fast equal head. So that's going to be our pointer. So we're going to go ahead and initialize a while loop. That moves the fast pointer quickly and the slow pointer not so quickly. So while fast dot next and fast dot next, which is twice as fast, as long as those are there. Oops, not Python. We'll let slow equal slow dot next and fast equal fast dot next, since we're moving 2 spaces instead of 1. So we'll go through there and initialize those pieces. So we'll go ahead and initialize a second half that will use a second function. The second function will essentially reverse the list for us. It's easier to just write it as a helper function. So function reverse list head. So we'll go ahead and initialize that, and then we'll come back there in just a second. So we'll go ahead and just put the second half meaning the second half of the list, and then we'll use that function and then pass in the, slow dot next. And then we'll put two pointers. One of them is going to be the first half pointer, and then we're going to set that at the head, and then we'll have the second half camel case, second half pointer equal to the second half. So essentially what we're doing is we're going to have a pointer at the head, we're going to reverse the second half, and then start it at the head of that second half. So we can kind of just iterate on down. Like we're going the same way, so we don't have to go backwards since it's a singly linked list. So now that we've got that reverse list, let's go and write that real quick. So in order to reverse the list, we'll have, we'll let the previous equals null, and then we'll let the current equal the head. So we'll start at the head, previous is going to be null. So while current is still there, we're going to go ahead and set a temporary variable that is the current.next, and then the current.next is going to be the previous, and then the previous is now going to become the current, and then the current is going to then be the next temp. So it'll essentially take the front, put it to the back, and so on, and initialize those pointers. So once you're done, we'll just return the previous, and then that will return that full reverse list back to that second half variable. So moving on, now that we have a second half that's reversed and the first half that's going forward, we'll initialize the result to automatically equal true, and we'll see if we can prove that wrong. So we'll go into a while loop that while there's a second half pointer, we'll go through and do a couple conditional statements. So while there is a second half pointer still, we'll say if the first half pointer value is not equal to the second half pointer value, meaning if the first node of that second half and the first node of the first half is not the same after we reverse them, we're going to initialize that result equal to false, because we've proven that wrong, and then we'll break out of the loop. Since we're done, it's already proven that it's not a palindrome, so we can short circuit it a little bit early. If that is not true, however, we'll just move on and then continue that while loop. So we'll set the first half pointer equal to the first half, and then the second half equal to the second half pointer dot next. That way, as it continues to go through, it'll just be pointing to the next one, and then continue that statement until it goes all the way through. If it goes all the way through, all we'll have to do is return the result, since it's true automatically, so it just checks through all those pieces. So this is our, technically, we have a O of n step here, and then we have an O of n step here, since it goes through each one of them, one of the elements in the list, but we'll drop that 2 from the 2 of n, and then it'll just be O of n. So given that we did everything correctly, we'll go ahead and run it, see if it works. Looks like it accepted, and it looks like we did pretty well. So in looking in this, looking at the big O analysis, like I said, since both of these are loops, it goes through each element of the array, or the list, but it's in linear time, so essentially it'll just be O of n in time. So there you go.